All right, now we're going to do high level chapter 3, section J, and high level chapter 3, section K. We're going to start off with magnitude and direction of vectors. So magnitude is the length of the vector. So in order to figure out the length of any line, I have to use the distance formula. Okay, so to figure out the distance formula, um, you should use x2 minus x1 squared plus y2 minus y1 squared, right, for the distance formula. But since this is starting at 0, 0, from here to here, the x distance is 3. From here to here, the x distance is 4. Okay, so we use that to figure out the distance. And we would get the square root of 9 plus, plus 16. And if I use my calculator, square root 9 plus 16, gives me the square root of 25 equals 5. Okay, so that's how you find distance vectors using the distance formula. Okay, and we would also, the distance, another word of distance is magnitude. So they may ask you for the magnitude, and you're really asking for the distance. Okay, now direction vector, we need to go back to our geometry days. Direction, if I want to know the direction, I need to know this angle. Now, in order to figure out the angle, I'm going to use some old-fashioned SOHCAHTOA stuff. Now, if for this angle here, for this vector here, if I want to figure out that angle, I need to use tangent, because here I've got the opposite side. We know that's 4. Here, the adjacent side, we know it's 3. It's going over 3, up 4. And tangent is equal to opposite over adjacent, right? So the opposite side is 4. The adjacent side is 3. So I'm going to write it as tangent of the angle equals 4/3. Now, if I do that with a calculator, 4 divided by 3, I get this number, right? Now, if I do second tan, and then the previous answer, and I hit enter, and then I'm going to get 53.1 degrees. Okay, so if I do the inverse of tangent of 4/3, I'm going to get 53.1 degrees. Okay, and that's it for H3J. Now we're going to talk about H3K, three-dimensional vectors. So as we've talked about before, 0, 0 is the origin, right? And so if I want to go talk about the vector where I've got going from the origin to A, I could write it like this, and this is called component form. And we can also write this with the ij. Now, if it's 3 dimensions, we have to have k here. And this is called vector form. Okay, so if I wanted to rewrite this in component form, it looks like this. If I want to rewrite it in vector form, it looks like this. These are the same. Okay, and whenever we start at the origin to a point, that is called a position vector, whenever we start from 0, 0, 0. Okay, now if I want to find the distance from the origin to A, as I mentioned before, that's the same thing as finding the magnitude. Okay, so to figure out the magnitude, I need to use the distance formula, and we always write that kind of with this absolute value sign. That means whenever you see absolute value signs, that means we're finding the magnitude. Okay, so if I wanted to find the magnitude of OA, I know that I need to go 1 squared plus 5 squared plus 8 squared, and then that's going to give me the square root of 90. which is equal to this. So this is my magnitude. That's the length of the line. Okay. So what if I wanted to figure out the vector from A to B? So if I had the origin here, let's just say A is somewhere over here and B is somewhere over here. If I'm going to go from A to B, that could be written like this, right? Okay, let's pretend you're going from San Francisco to San Jose. I could go directly there. Or I could stop in Oakland, couldn't I? So I could go from San Francisco to Oakland and from Oakland to San Jose. Do I end up at the same place? Yes. So basically what I'm saying is to go from A to B, I can go from A to some letter and then plus that letter to B. We end up with the same thing. Okay, so if I'm going from A to B, I know that I could go from A to the origin and from the origin to B. But in order to get A to the origin, we know the origin to A is this, right? So to switch this around from O to A, we have to change the signs of the 1, the 5, and the 8. So that's what we do right here. So the 1, the 5, and the 8, I'm going to change the sign. And then when I change the sign, I've got -1, -5, -8. And -1 plus 2 is going to give me 1. -5 plus -1 is going to give me -6. And -8 plus 5 is going to give me -3. All right, that's your lesson on 3D vectors. And I hope this helps. Watch this again and take careful notes. Let me know if you get stuck.